Hello and welcome back. Today we're going over 2.4, our library of functions. And piecewise defined functions. So these are the functions that we're expected to just sort of be able to sketch the basic one, so the no frills, just one thing happening to our input each time. We're expected to know how to do each one of these. So I'll start with the square root function. So just f of x is square root of x. So these, you have to kind of be mindful of your inputs if you want to stay on corner points. So for example, square root of 0 is 0, square root of 1 is 1, but the next perfect square after 1, we're all the way to 4. So square root of 4 is 2, square root of 9 is 3. And we would go forever that way. We can take square roots of negatives, but that would kick out imaginary numbers for us. And remember, the x-axis and y-axis are real number lines. The imaginary numbers you see in, once you hit calc, how to sketch those. But graphing the real number plane, we don't have anything back here. So as far as the parity, even, odd, or neither, we don't have symmetry about the y-axis or the origin, so this is neither even nor odd. This is increasing on 0, infinity. There's some debate as to whether or not we should include the 0 on that. I'm in the camp of saying we exclude it. Domain, we are allowed to use 0 and get an output for it if we have 0 as our input, and we can plug in as big a number as we want. Our corresponding range values, as you can see, our lowest y value is 0. We're increasing, not quite as fast, but we are increasing forever. So we have a global min of y equals 0 at x equals 0. The next function that they're expecting us to sort of just know how to work with is the cube root function. F of x is cube root of x. So same idea, cube root of 0 is 0, cube root of 1 is 1. The next perfect cube after 1, though, is all the way at 8. Cube root of 8 is 2. And unlike an even root, an odd root can take in negatives just fine and keep you in the real numbers. Cube root of -1 is -1. So remember, cube root of -1 is asking you, what can I multiply 3 copies of to get a -1? Well, if I take -1 times -1 times -1, I do indeed get that -1. Similarly, then, cube root of -8 is -2. We're symmetric about the origin, so this is an odd function. Increasing the entire real number line. Moving from left to right, we're always moving up. Our domain, -infinity to infinity, so is our range. And since we're going up forever, going down forever, we have no global extrema. No highest point, no lowest point. Global, remember, sometimes they'll also call that absolute. All right, so next up, we have our identity function. Or, I'm sorry, we'll do the absolute value before we get that. So f of x is absolute value of x. So absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2, and so on. Absolute value of -1 is +1. Absolute value of -2 is +2, and so on in that direction. So if we have just our basic absolute value function, we have that characteristic V shape. It meets at a right angle, assuming we have just a coefficient of 1 on it. So our parity, sorry, I smushed my P in there a little bit. Parity, this is symmetric about the y-axis, so this is an even function. We are decreasing on -infinity, 0, increasing on 0, infinity. Again, the author, I can't remember where he fell on that. He may have had brackets on those guys. I would argue that a point should not be considered to be both decreasing and increasing, one or the other. It should not be able to be both. Our domain, pick a number on the real number line. You can take its absolute value. Our range, though, lowest we go is 0, and we can rise forever. So that means we have a global min of y equals 0 at x equals 0. As mentioned, the identity, that one's a pretty quick one. F of x equals x. Whatever you put in, that's your output. Put in a 0, your output's a 0. Put in a 1, your output's a 1. Put in a 2, output's a 2. Put in a 3, output's a 3, and so on forever in both directions. This way, put in an -10, you get a -10. We're symmetric about the origin, so this is an odd function. Increasing forever, -infinity to infinity. Our domain, all the real numbers as well. Range, we drop forever, we rise forever. Which means then we have no global extrema. Square function, that one again we won't spend a ton of time on. F of x equals x squared. You graphed lots and lots and lots of those in your Math 100 class, or the equivalent you took somewhere else. So 0 squared is 0, 1 squared is 1, 2 squared is 4. Just do whatever the name is to your input. 3 squared is 9. -1 quantity squared is 1. -2 quantity squared is 4. -3 quantity squared is 9. So your basic parabola. Symmetric about the y-axis, so this is an even function. We are decreasing on -infinity, 0. Increasing in value once we get past 0. Our domain, pick a real number, you can square it. Our range, however, the lowest value we have is a 0. we can go up forever, which means we have a global min of y equals 0 at x equals 0. The cube function, f of x, is x cubed. 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. That's off our grid, so we'll go the other way. Negative 1 cubed is negative 1. Negative 2 quantity cubed is negative 8. We're symmetric about the origin, so this is one of our odd functions. We are always increasing as we move from left to right. And of course, if we're increasing from negative infinity to infinity, that means our domain also had to be negative infinity to infinity. Our range, also, we could drop forever, we could increase forever. So no absolute extrema. Also called global extrema. Either name is fine. All right, so just 2 more of these, and then we'll play with our piecewise guys. So the reciprocal function. This is the one, the first one, where I'm not going to try to just put my dots on nice, neat corner points. F of x is 1 over x. So 1 is its own reciprocal. The reciprocal of 2 is 1/2. Reciprocal of 3, 1/3. Reciprocal of 4, 1/4. Reciprocal of 5, 1/5. As I keep putting in bigger and bigger inputs that are still positive, the reciprocals are getting closer and closer to 0, but staying positive. So we approach the x-axis but don't touch it. It makes it into what's called an asymptote. But notice in here, if I put in a 1/2, the reciprocal of 1/2 is 2. Reciprocal of 1/3 is 3. Reciprocal of 1/4 is 4. So that's also heading towards the y-axis that way. And -1 is its own reciprocal. Reciprocal of -2, -1/2. Reciprocal of -3, -1/3, and so on that way. Reciprocal of -1/2 is -2. Reciprocal of -1/3 is -3, and so on. So this is symmetric about the origin. So this is an example of an odd function. We are decreasing negative infinity up to not including 0. We are then decreasing again. So we will just union that with 0 to infinity. We can't just say we are decreasing everywhere, because we have this change in behavior from negative outputs to positive outputs. And notice 0 is out of our domain. Division by 0 is undefined, so our domain looks the same. Negative infinity up to but not including 0, union 0 to infinity. Range would look the same as well. We'll get close to this x-axis, but we'll never reach it. So we have no global extrema. So then our last one before we get to play with a piecewise function is the greatest integer function. It's written in kind of an unusual way, int of x. So this says find the greatest integer that is less than or equal to your input. So 0 is already an integer. Greatest integer less than or equal to, say, 1/2 is 0. And that'll keep happening up to, but not including the 1. At the 1, we pick it up. Greatest integer less than or equal to 1 is 1. And 1.1, 1.2, 1.3, those all get dropped down to 1. Until the 2, we have another jump. And another jump. And so on. This would continue this way and the other way as well. So I'm just going to draw kind of that much of it, and you can kind of see how it would fill out. It looks like a set of stairs. This one we're not going to worry about discussing domain range, all that stuff. I just wanted you to kind of see this. The author introduces it. It's an interesting function to play with. And then the last one, as I mentioned, we get to play with a piecewise defined function. So let's see, we'll do f of x is opposite of x if x is less than -2, x squared if -2 is less than or equal to x, which is strictly less than 2, and it'll behave as x if x is strictly greater than 2. So basically what I've done is I've got this real number line into strips. So one says, okay, behind the -2, it's acting like this function. If I were to be able to actually use the -2, I would get opposite of -2, +2 for a result. And I can get close to there, but I can't reach there. I tell the reader that by putting an open circle there, just like on the greatest integer graph. And then this is a linear function with a slope of -1. So on each of those points, as I go to the right, down 1, right 1, down 1, right 1, slope of -1. Then once I pick up the -2, now I'm acting this way on this little strip of land between -2 and +2. It will look like a curve on that. So if I plug in my -2, I get a +4. We said or equal to the -2, so I am allowed to put a solid dot at -2, +4. -1 is on that interval as well. That squared is a 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Strict inequality here, though. So we'll have an open circle at 2, 4. So then I connect those guys up with a curve. Anything to the right of 2, so there's my third chunk of the graph, is going to act like this last part of the piecewise function. It'll act like the identity function. We have open circle on this as well. If I plugged in the 2 and said, okay, we're getting very, very close to it, my output would still be 2. So I have an open circle at 2, 2, and then I have a slope of 1. So it basically just says, use these things to figure out where the change in behavior happens. X is less than -2, it'll act like y equals -x. If it's between -2 and 2, it'll act like y equals x squared. If it's past 2, it acts like the y equals x. So notice here, this function is actually not defined at 2. If I asked you to find f of 2, undefined. They didn't tell us what to do if x was worth 2. So that does happen. Sometimes you will have gaps. Sometimes these points will meet with the change in behavior. Sometimes they won't. All right, so in 2-4, I would recommend trying 1 to 26 all, 27 to 49 odd, 51, and 55. If you're looking for a challenge problem, again, not required, the challenge problems, 57 or 61. If you have any questions, come see me. Or, well, not in person, obviously, but in Zoom or email. Otherwise, I'll see you next time.